Chapter 4 is all about the physics of sound, waves, the motion of waves, the production of sound in speech, and then the detection of sound in hearing. We will see many examples of waves. For example, you can have mechanical waves like waves in water. In fact, that's a great example to think about certain types of waves. But then we also have sound waves, which are a different category of wave, and light waves, just many different examples of waves. There are other types of mechanical waves, like waves in water, like a slinky. You can have a wave traveling through a slinky or on a rope, a wave like this. Waves are periodic in nature. And when I say they're periodic, it just means that they repeat. They are called periodic waves. A standing wave, the wave travels back and forth through the medium. And repeats so that it looks like the wave is not moving. You might have done this before, like where you have a rope and you're moving it up and down. So let's say that you have a rope and it's attached to some object, and you stand here, like where you have the ropes and you're moving them up and down, and it looks like the wave, if you get it just right, it looks like the wave is standing there, like it's not moving at all. You may have seen that before, actually done that with a rope, and if not, try it. We'll do it in class. But this is called a standing wave. Sound waves are periodic. For example, a sound from a guitar is periodic. And remember, when I say periodic, it just means that it repeats over and over. A clapping sound is also periodic. It just lasts for a very short time. So sound waves will always repeat. Sound waves have a medium. Usually, when we're just standing around talking, that's going to be air, but we'll see that sound can travel through other things, water, steel. They require a medium. When it's in air, they cause the air particles to move up and down, or side to side, rather. Usually not forward. We'll see this later, but when I have a sound wave that's traveling through air, the sound waves, if I have a particle of air right here, it'll move back and forth, but this particle of air will not move forward. Okay, we'll see that a little bit later. We'll talk about that. We have two different types of waves, transverse and longitudinal waves. Transverse waves make the medium move up and down. This is probably what you think of when you think of a wave, like a wave on the water. So if I have a wave moving through water, if you imagine a particle of water, as this wave moves through water, it will move up and then it'll move down. It'll move up and then it'll move down. It'll stay in this one location, but it moves up and down as the wave travels through the medium. Longitudinal waves make the medium move back and forth. Oh, by the way, this up here, this is the transverse waves. This is like the wave at a football game. That's a great way to think of waves. In a football game, the medium in that case would be the audience, and the audience moves up and down, up and down. The people don't move around in the stadium, they just move up and down in their seats. So that's a great example of a transverse wave. It's not exactly the same, it doesn't have all the same properties, but it's a great analogy to think about. In a longitudinal wave, the medium will move back and forth. And so a sound wave, which is a longitudinal wave, will make your air particle to move in this direction, in this direction, in this direction, in this direction, as that sound wave moves through space. Two different types of waves, transverse waves and longitudinal waves.